In problem number 11, we have a different kind of parabola than we've seen in the previous example I did on the video. This one, if you notice, let's go ahead and graph the vertex. It's at 0, 0. And it has a directrix at x plus 1 equals 0. Well, a directrix is either going to be a horizontal line or a vertical line. So let's solve for x. Let's subtract 1 from both sides. And we find out our directrix is x equal negative 1. So it's a vertical line through negative 1, and so I'm going to sketch that in right now. Okay, now this means that our parabola is going to open like this. It's going to open to the right, and so we have a slightly different kind of equation for that. If you look on page 414, it's x minus h equals a times y minus k squared. Okay, and again, a is equal to 1 over c, so that's going to help us in a minute get our a 1 over 4c. It's going to help us get our a in a second. Now, if our vertex is 0, 0, that's our h and our k. So it's going to be x minus 0, which is just x, equal a, y minus 0 squared, which is just going to be y squared. So really all I have to do here is find my a. Now, how am I going to find the a here? We know that our directrix is x. Our directrix is x equal h minus c, okay? Well, what is our directrix? It is x equal negative 1. So that means h minus c is negative 1. Okay, let me just kind of separate that a little bit. Now, I know what my h is. It was 0. So 0 minus c is negative 1. So minus c is negative 1, and if you multiply both sides by negative 1, we get c equal 1. So a is equal to 1 over 4 times c, and c is 1, so a is just going to be a fourth. So our equation here is going to be x equal 1/4 y squared. It's kind of a simple looking equation because we have a vertex at 0, 0. Alright, so now I can go graph this. And let's see, I've got my vertex. I know my equation. So what I could do is let's make a little chart over here. If we know our directrix is 1 away from the vertex, we know our focus is right here. We always want to put our focus on the graph, so I'm just going to put a little S by it. I'd really need to get at least one more good point on this parabola. So what I'm going to do is just plug something into the equation. Since x is 1/4 y squared, let's find something like let's say, what if y were 2? I'm going to actually plug in the y, 1/4 y squared. What if I plugged in y as 2? That would give me an x that would go with it. And the reason I picked 2 is I'm kind of thinking, well, 2 squared, let me just write that, plugging in y is 2. 2 squared would be 4, and 1/4 of 4 is 1, so we get x equal 1. So we've got the point 1, 2. Now, if there's a point, if you think about it, we can actually draw our axis of symmetry in here. It's going to go through the vertex and the focus. It's going to go like that. So if there's a point 2 away on this side, there will be another point 2 away on this side. So we can kind of get a sense of the parabola and just a rough sketch of it there and make it go through those points. But we've got our directrix graph, we've got our focus graph, we've got our vertex, and we've got a couple of points. So this is a pretty good representation. Number 17, they want us to find all the different parts of this parabola represented by this equation. And so if you look at this, there's one thing that we can tell right off the bat, and that's the vertex is 0, 0, because we don't see anything subtracted from the x in parentheses, and we don't see anything subtracted from the y. So we got a vertex of 0, 0, and I'm going to actually write this stuff down as we find it down here. That was one thing that you could find just right off the bat before you knew anything, just because you didn't see any subtraction or adding signs. Now, we've got a y and we've got an x squared term. That tells me my parabola is going to open up. Since it's a positive 1/6, it's going to open up. That means that if this is my vertex, my directrix is going to be somewhere on the y-axis, and my so we're going to want to find the focus, and we're going to want to find the directrix. The directrix is going to be a horizontal line. Since this thing opens up, it'll look like that. So it's going to be y equal something, okay? Now, what we know is we don't really have a whole lot of values here. We do know that our h and our k is 0, 0 here. That's our vertex. We also have this a value here of 1/6. And I don't know if you look at that box on page 414, a is equal to 1 over 4c. So if you cross multiply, you can solve for c. 1 times 4c is 4c, and 1 times 6 is 6. So c is equal to 6 over 4, which reduces to 3/2. So now I know that c is 3/2. How does that help me? Well, if you look, your focus, which we don't have yet, is given, they tell you that it is h and k plus c. Well, we know that h is 0, we know that k is 0, and now we know that c is 3/2. So our focus is going to be 0, 3/2. So let me write that down here. We're running out of room already. Okay, I'm going to turn this off and graph some of this just to save some time on the video. Now, since our focus is 0, 3/2 and our our vertex is 0, 0, I know my directrix is going to be a horizontal line y equal, and it's going to, since there's 1.5 units between the vertex right here and the focus, it's going to be 1.5 down the other way for the directrix, so it's going to actually go through negative 3/2 here. So the directrix is going to be y equal negative 3/2, and the reason I know that is it's the same distance from the vertex to the focus as it is from the vertex to the directrix, and I knew my directrix was going to be this horizontal line. Okay, now the axis of symmetry, that goes through the focus and the vertex, so that's going to go like this. And the axis of symmetry, I'll just put axis, I can't even read that, of symmetry is going to be x equals 0. It's a vertical line through 0, so it's x equals 0. Let's see what else they ask us to find. They wanted the vertex. We got it. We've got the focus. We've got the directrix, and we've got the axis of symmetry. Now we just need to graph the parabola. Well, what I would do here is just find another good set of points. We know this thing's going to open up. So we can make a little mini table of values. I'm going to do it down here below in the graph, on the graph paper, just because I've got some room now. If I plug in x is, let's see, if I plugged in x is 6, 6 squared would be 36, and a 6 of 36 would be 6. So there's the point 6, 6 on this parabola. So let's put it here. And since it's 6 units away from the axis of symmetry, which is the y-axis in this case, I can put another point the same distance away on the other side, 1, 2, 3, 4, 5, 6 over here. So if this is my vertex, I know now that this is going to do something like this. And of course I didn't do a great sketch. Let's see if I can undo a couple of things that I did there. Let me try that again. Do something like that, okay? It's a little bit better. So there's our parabola, and there's a lot of the information that they asked for down here at the bottom. So just make sure you're answering all the questions correctly. Anyway, we did pretty good. Got all this, that's all done on 17. All right, you look at this number 19. It's got a lot more terms than number 17 did. So we're thinking, what should we do here? We are probably going to need to complete the square. So I'm going to write in blue. I noticed that I've got a y term and a y squared term. So if you remember what we do when we complete the square, we take this coefficient of this y here, and I'm going to take it. It's negative 4 over 2. I'm going to divide it in half, and I'm going to square it. Well, negative 2 squared would be a positive 4, so on the other side I'm going to add the 4 there as well. So what I have now is 4x plus 4, and over here what I've created is a square y minus 2 squared. That's looking better because I know that if I've got something subtracted from a y, that's going to be my k. Right now I can already tell you that my k is equal to 2 here. Let me kind of write that down here. K equal 2. Now what about on the right hand side? Do you notice that you could factor a 4 out of both of those numbers and you'd get 4 times x plus 1? Okay, let's write our equation. This has got a y squared and it's got an x in it. Let's see, what do we usually want? We usually want, I should put this in parentheses, shouldn't I? We want the a term to be in front of the square term. So let's divide both sides by 4 now. Dividing by 4 is the same thing as multiplying by a fourth. So when I rewrite this, I'm going to write this as x plus 1 is equal to 1/4 y minus 2 squared. Alright, now this is x minus h equal a y minus k squared. And if you look at this format, this is going to be a parabola that opens to the right. It's a left-right kind of parabola because the y is squared, and since it's a positive number in front of a, we know that it's going to open right. Okay. So now we know that if you look at it, our vertex is HK, right? Well, what is H? It looks like a positive 1, so it's really a negative 1 because it's the opposite of what it looks like. And the K is 2. So H is negative 1, K is 2. Now, if you think about it, there's another number we have here that we know, and it's this 1/4, which is our A. If you remember, A is 1 over 4C, right? Well, if it's the same thing as a fourth, what is C going to be? If you notice, if it's 1 over 4, doesn't C have to be 1? If you don't notice that, cross multiply. 4 times 1 is 4, and 1 times 4C here is 4C. And if you divide both sides by 4, you get C equal 1. Now this is going to help us find everything. We've already got our vertex. Let's put it on there. Negative 1, 2. It's going to open to the right. And we can find our focus. Okay, so let me just come over here. I'll just use some of this space here. Our focus is H plus C. Can't read that. It's not taken. Comma K. So H is negative 1 plus C is 1. And then our K here was 2. So that's going to be 0, 2 is my focus. So let me put that on there. Okay. Now, if my vertex is negative 1, 2, and my focus is 0, 2, there's only one unit between those. That means if I start at this vertex here, this is the focus right here, the vertex is the point that's to the left. If I go 1 unit away, the same amount away on the other side, there's going to be my directrix. So my directrix, if you look at it, it's going through the line. It's a horizontal line. I'm sorry, it's a vertical line. So it's x equal, and it goes through negative 2. So there's the directrix. There's my focus. I'll put an F in front of it. There's my vertex. My axis of symmetry, I'm going to draw that in. It goes through the focus and the vertex, so it's going to go like this. So my axis of symmetry, I'll put it right down here, axis. I'm just going to write axis here since I'm so short on room. If you look at that, that's a horizontal line, so it's y equal, and it goes through y is 2. Okay, so we found all the parts that they want, and I've circled them all. 4 different things they asked for. Now they want us to graph it. Okay, so we could figure out some points that go in here. I am thinking I'm going to have to go to another piece of paper and figure this out. What I think I will do is plug in y is 0. I'm going to plug the 0 in because it's easier to do that. If you plug in y is 0, you're going to get 0 squared is 0, minus 4 times 0 is 0. So we have a little equation, 4x equals 0. I'm just plugging it into that original equation. And if you have 4x equals 0 and you divide both sides by 4, you get x equals 0. So we have the point 0, 0, which is right here. It is 2 away from the axis of symmetry, so there will be another point 2 away on the other side of the axis of symmetry. So I've got some points now, and I can try to just sketch my parabola. I'm going to sketch it in black. I'm going to sketch over it in black to try to just highlight where the answer is, since it's kind of hard to see that green sometimes. I'm kind of missing that point there, but you get the idea. That's a rough graph of our parabola, and if you notice, it would not be a function. So if you tried to get this in the calculator, you'd have to solve for y, and then you'd have to type in 2 different equations because your graphing calculator wouldn't graph that because it's not a function. So that would be kind of hard to get it on the calculator. But anyway, we've got a graph here.